My name's Jim Hedges. I'm our Director of Sales. I've got two of our agronomists over here, Jamie Brand, raise your hand, and Aaron Phillips. And anyway, you heard Greg talk about peaks and valleys. And when I think about yield, I always think about yield in the aspect of peaks and valleys, because I don't think there's one of us that haven't been out in a combine and went from one end of the field to the other end of the field and seen over 100 bushel yield difference. And I know my dad used to say to me, Jim, that's just the way it is. And the challenge to all of us is just because that's the way it's always been doesn't mean that's the way it has to be. We have management techniques, we have this application type equipment, we have tools that can tell us real time how much nitrogen we have left. We need to embrace those tools to make a difference in yield. This is an example. It's a yield map from one of my farms from last year. And you can see vividly these two lines where the yield is very variable. As a matter of fact, there's over 100 bushel of variation in those lines. That's a standard fall applied anhydrous with an inhibitor program followed up with about 30 pounds of weed and feed. So the fact of the matter is we were shooting for about 220 bushel yield goal, and we achieved it in those strips. So we got 220 here. So my question to all of you is, should I be happy with that? And the answer is obviously no. I shouldn't be happy with that because I had a perfect year in central Illinois. I farm about 90 miles southwest of here, and the conditions were just absolutely ideal. So if Mother Nature gave me the right rainfall, gave me the right growing conditions, and gave me the potential to go out to get 270, 280 bushel corn, why wouldn't I want to go get that? So by front loading enough to make it to V12 to V14, and then coming in and understanding where I was at, how much nitrates do I have left, I was able to do a static rate here where I increase yield nearly 40 bushel, and then going to variable rate, I'm increasing yield by over 40 bushel. So huge impact from just changing the way I'm managing my nitrogen. How's it look real time, real world? This is a shot from Indiana where we have a grower who's helping us with these 4 quads of different management practices. And here you see peaks and valleys. This is another standard. It's a total 100% spring pre-plant nitrogen, corn on beans, and we're comparing it to a spring pre-plant where we load up enough, once again, to get the V12 and then come back with a Y-drop application in that V8 to V12 stage. Here's what's really interesting about this. This is the planting date is basically the same. It's the same RM hybrid, and it's the same amount of nitrogen. But look at the valleys out here and very few peaks and what we've done over here. We've been able to pull those valleys of yield up to the peak. And if we want to have impact on driving whole field yields, that's what we have to do. Bring those valleys up to the peaks. I love Soil Scan. Have you all been through the Soil Scan? Okay. Soil Scan gives me the ability as a farmer to answer a question that I never was able to answer before. How much do I have left? And how much do I need to finish? Particularly when I'm looking at technology like Y-drop over here for application of nitrogen, I need to know that. If I have that type of knowledge, I can make better decisions. Those knowledgeable decisions help me not only drive more yield, but also be very frugal with my inputs. So our goal is to get more bushels out of every pound of nitrogen. You heard Greg talk about we got down in the 0.7s. Now that's probably kind of an outlier, but why shouldn't I shoot to get a bushel out of every 0.8 of a bushel of nitrogen, especially when we see commodity prices that are tight? Here's an example of somebody that answered that question, not from a management standpoint, but from a rescue standpoint. So that light yellow strip is 170 pounds of spring applied anhydrous with an inhibitor followed up by 40 pounds with the planter. So 210 total pounds down, and that was the plan. The plan wasn't to have tumultuous rainfall. This is in Indiana. But we're seeing these type of weather events more and more often, and I think we have to think about that as we manage our whole nitrogen program. We came out with a soil scan type technology and look at this and say, here's how much you've got left and here's how much you need. We come out 60 pounds rescue. Look at the impact. That is having a dramatic impact on yield. This is a chart I use at pretty much every speaking event I go to because it tells a wonderful story. It tells the story of when corn is hungry. V10 corn. This corn right out here by the side dress bar is, Jamie, you've V9. So V10 corn is anywhere from here to here. It's only used 25% of its total nitrogen. 75% of the needs of that plant are yet to be taken up. So with that question, and Greg asked the same question, why would I want to go do a 100% application, whether it's anhydrous, urea, UAN, or why would I even want to do a split application if it's too early? So here we see side dress application, but we're probably out here at V2, V3. And once again, how much nitrogen have we used at V2? Very little. If I go to V10 and do my application, all of a sudden I've gained 8 leaf stages of knowledge. That's tremendous because each leaf stage is 2.5 to 3 days. So all of a sudden I have 21 to 24 days more of knowledge about what the environment has given me from a potential standpoint. I know how much rainfall I've had. I know what the environment's been like. I know what the forecast is. And knowledge gives me the power to make much better decisions. Y-drop gives us the ability to apply those decisions. This type of technology gives us the ability to do 3 things that are really, really unique when you think about side dress application. Precisely place the right amount from a volume perspective of nitrogen, not only on the field, but in the strip, all the way down to the grid, if I would so choose to do variable rate nitrogen. Think about the technology in the cab of that Deere or this Miller or the Heggie that you saw over by the tent. That technology from a precision standpoint allows us to do that type of application and have that type of impact. Secondly, placement is absolutely key, and you're going to get tired of hearing me talk about that, but when we come out, we need to place that nitrogen right next to the corn stalk because it allows us to take advantage of the physiology of that corn stalk. Think about corn once it's canopied. It has its leaves out here, and corn is greedy. It's going to grab every single drop of water. It's going to grab every single drop of dew, and it funnels it down because of that unique physiology right to the base of the plant. This is a shot I took about 4 or 5 hours after 1/10 of an inch of rain. I've got a 5 to 6 inch muddy strip there. We've seen heavy dews. We get stem water with dews. This is enough for us to get incorporation of the nitrogen if we can get that type of placement right next to the stalk. And that's where we want it because where's the root mass at? Think about from a physiology below the ground. It's a nodal root system, right? It's going to grow out, but it grows out and down, out and down. We get much quicker uptake. I was talking to a gentleman earlier. You said that you're seeing within 24 hours a visual of the difference because of the placement. And here's why. I'm dropping it right down where 80% of the mass of that root system is, right where that superhighway to transport that up into the plant. So not only do I get quicker utilization, but our goal of getting more pounds of nitrogen into the plant and less down the river can be achieved through this application methodology. This is some work that the Iowa Soybean Board did. It's from their on-farm network program, and they use soil scan technology to really try to understand what placement does from a concentration standpoint. So here we're seeing spring applied anhydrous, side dress, and here's your 30-inch rows, right? So visualize a corn plant here and here, and as we take our soil cores, we can see all the way to 12 inches, we basically have no nitrogen. So all the nitrogen's right here. Now let's move this and think about if this is my row, how much root do I have getting into that nitrogen? I've got root that's coming over here, but if I can slide this back to where the root is, I'm going to start to intercept much more of the nitrogen much quicker. That's why placement is critical to not only uptake and utilization, but also the speed of that uptake and utilization. Here's a really nice visual of a Coulter system versus a Y-drop. You can see from this overhead shot, this corn is much lighter, so it's not building as much chlorophyll. It's a lighter green, and we know if it's lighter green that yield potential is getting chipped at right now. Anytime I see a visual like this corn is not having nearly as good a day as this corn. And we don't want to ever see that. This is a Southern Illinois yield trial where you see two things. Here we see a coulter at V4 versus a wide drop at V7. So placement does matter here once again. As we see firing coming up, we see a lighter green, but we've also started to feed this corn when it's hungry. Once again, think to that nitrogen curve. We're just starting to get into where the steep uptake of nitrogen is going to occur. The wider window of application is probably just as important as the placement. Once again, when we think about the nitrogen use curve, why do I want to go out early? I want to go out in that V6 to V12. So this is actually my sprayer sitting right here. I've been out in V12 corn. Jamie, you've sized this corn right over here in front of the miller. It's V11. It's V11, so it's corn about this tall. No problem going through that. And I'm in 20-inch rows with 26-inch trams. And it gives me the ability to do something I never thought I'd be able to do, apply nitrogen when I have that much knowledge. And that ends up in, once again, better decisions. I'm also really excited about Heggies and Millers because think about the endless possibilities we have, not only from a wide drop perspective, but from an undercover perspective on putting nitrogen or other nutrients or fungicides or insecticides or micronutrients. It's a endless world of possibilities that none of us even probably thought about just a couple years ago. Here's some other visuals. This is a field that used 100% pre-plant nitrogen. You can see the streaking. You can see the peaks and valleys. Here we have pre-plant nitrogen followed by wide drop. Once again, we're demonstrating pulling that valley up to the peak. We're getting more output with less nitrogen. Greg used this, but this is another one of our yield trials. What we like to do, and we're doing this across the whole U.S., is go out to a grower and say, let's apply your system versus our system, because seeing and believing and experiencing it is probably the most powerful way to make someone change their behavior. This 200 pounds of anhydrous at pre-plant, not only is the gas tank starting to run dry, we're seeing the knife-to-knife variability, which we can fix with Equiply, but what if we use that Equiply to put on 100 pounds here and then came back in with wide drop? Even coming in with 50 pounds at V6 and 50 pounds prior pre-plant and then 150 of wide drop, you can see the dramatic results we're seeing. But I see V12 versus V6, even better results. So once again, we need to front load enough nitrogen to get that corn to V12, and then we're going to really grab as much potential as there is out there. Would I suggest going out with only 50 pounds to stretch to V12? Probably not. I would probably go out with 100 pounds, regardless of the form. This is a coulter versus a wide drop. And here, it's not as vivid, but you can see the valleys, the lighter green. And then this is a side dress application. So we're out here side dressing 150 pounds at 624 versus a wide drop at 7.8. So what have I done? I've pushed back into that window of when the corn's really getting hungry. I know a lot more about what the environment has given me, and because of that, I'm able to actually apply less. And look at the dramatic results we're going to see out of this. This is going to be tremendously higher yielding than this. So once again, getting more bushels out of every pound of nitrogen. And it also answers another question that I get frequently, or a concern. I don't want to go out with that tool and tear up my end rows. Turning on your end rows, I'm going to slaughter it. Actually, look, you can see very little damage. When I harvest, after using this tool last year, very, very little damage. As a matter of fact, it's almost hard to tell you've been through there. Look at what we've done coming through with our anhydrous bar and tank. I go down, yeah, the question is, I go down the row with my 20s? Yeah, I've got 26-inch tram lines. So I'm in 20-inch rows, 26-inch tram line, and I don't have any problem. I steer, I don't use auto steer, but it's not an issue. I'll tell you, the first time I did V12 corn, I thought my skill set is not driving. I'm kind of ADHD, doing this, but it was fine. Here is probably one of the most vivid examples of the systems and how these differences can occur. And really change the potential of what we're going to grab out there. This is side dress anhydrous, side dress Y-drop. Side dress anhydrous, side dress Y-drop. Anhydrous, Y-drop. Pretty dramatic results. I also don't want to pigeonhole the Y-drop application system into it's only about nitrogen. It's about any nutrient that's limiting. We're working with partners in the industry like Winfield Solutions around what kind of products can I put through this as a nutrient cocktail to really have impact on yield. So sulfur, potassium, what about growth regulators? Here you can see we're looking at sulfur deficiency as we get this streaking in the newer leaves. And this was an actual trial where we came out and did a nitrogen-only application at V12 versus nitrogen with 2 gallons of thiosulfate, and dramatic impact. So it's about eliminating limiting factors. If I've eliminated nitrogen and then I can figure out what the other limiting factors are and apply, I keep raising the staves of the barrel that are chipping away at my yield potential. So this is a video that demonstrates what I'm talking about here. So we've re-engineered this, and this is the first year we've ran them, with one objective. It's all about placement. Right here you can see that placement. It's right next to the stalk. I call it the Wheel of Fortune effect. It's just clicking right next to those stalks and giving you that precise application. Here we've got slow motion close-up, and we're going to demonstrate this out here in just a few minutes. Secondly, it's about that window of application. So with a self-propelled sprayer that's standard like the Case or this Deere, we're able to go V6 to V12, but once again, with these higher clearance sprayers, the sky's the limit. We can get out there even up to R2 and do applications. So if I've eliminated nutrients as my limiting factor, now it's all about plant health, because green corn yields. If I can keep my corn green, and you can see here a trial from last year where we're completely filled out here to the tip, and look how green my canopy is. If I can keep that corn green, I can extend grain fill. If I can extend grain fill, I can take advantage of this right here. That's sunlight. That's free energy. I can convert that into carbohydrates. I can take those carbohydrates, I can shove it up into those kernels, and I can get bigger, longer, denser kernels, which allows me to manipulate the yield equation. Because people have told me, Jim, you've limited your yield on this field because you have no tip back. This is 20-inch rows, 37 to 38,000 final stand. So I don't want to plant thicker than that, honestly, because of variability. But what if I can go out here and not change the ear count and not change the kernel count, but by doing that carbohydrate shoving into the kernel, change the denominator on the yield equation? What if it doesn't take 90,000 kernels to make a bushel? What if it only takes 80,000 or 75,000? And the way I can do that is through our undercover application system. So this is an example of the spray pattern, and we're going to see this live in just a few minutes, but visualize this out in the cornfield and think about the coverage you're going to get. This is a trial. We also are working with BASF on Preaxor, so it's a blocking strategy. If I can go out and stop the disease before it hits economic threshold, if I can block it before it ever really gets established, what is that going to mean from a yield standpoint? So we're coming out with a Preaxor. This corn staged at V13. This is that sprayer right there. We do our application, and the coverage is outstanding. So this is the top of the canopy. This is the bottom of the leaf. This is the top of the leaf. And we're getting basically equal coverage of both. So why is that important? It's important because 60% of the stomates are on the bottom of this leaf. If I can push more product into that plant, I'm going to increase the efficacy of the product I'm using. So I can get more Preaxor in, I'm going to increase that performance, and I'm going to increase yield. Here you can see our first visual of the treated versus the check, and I can see gray leaf spot starting to come in already. Here it's more dramatic, so we're right at pollination. I'm seeing lots of gray leaf spot lesions here. This is my ear leaf. What's important about the ear leaf? It's the number one driver of yield for corn, and it's clean. I mean, it is beautiful. This was just taken about 10 days ago. This is 2 leaves above ear. See all these lesions. What are all these brown spots not doing? They're not photosyntheting, right? If they're not photosyntheting, they're not taking advantage of that free sunlight. They're not building those carbohydrates so we can manipulate that yield equation. Here's the same leaf. Look how incredibly clean it is. So I think we've got tremendous potential with this type of application technology. And I just wanted to show this picture. It's from a different field, but you can see how large these lesions are on this leaf. And we're well above ear leaf once again. And this was sprayed. It was just sprayed with a plane. So because of environmental conditions, obviously I didn't get good penetration down into that canopy with the plane. And I'm not throwing planes under the bus. They're always going to be a valuable tool for a rescue. But if we want to intensely manage, we have to evolve. And new technologies come along all the time that are better than the older technologies. And from an application standpoint, that's what Undercover does. It's a paradigm shift in philosophy of application. Instead of top down, why don't we go bottom up? Because we're going to get that better coverage and we're going to increase the efficacy of that product. Here's some trials that we ran at V7. So this leaf, and this is contact paper. So what contact paper does is it allows us to see what type of coverage we're getting. So any droplet that hits it, it turns it purple. Here I can see I've came in with Undercover, and look at the coverage I've got here. This is a plane. So I've got some coverage, but not nearly as good a coverage as here. But more importantly, what's going on the bottom of the leaf? Here's my Undercover. How many spots do you see? I don't see any. So I'm not taking advantage of the stomates on the bottom. We also don't want to pigeonhole Undercover into it's a corn-only product. The potential of Undercover is incredible. When we talk about this technology with cotton growers and peanut growers, I mean, they light up. When I think about it in soybeans, how many of you have ever had spider mites in soybeans? Yeah. Why can't we effectively kill them? Because we're trying to penetrate and we can't penetrate. Going in from underneath the canopy and spraying out and spraying where they live not only vastly depopulates and kills more of it, but it stops regeneration of that population. So we're going to get longer, more effective control. Wheat is also a crop that we think we can have tremendous impact on. Here you see the flagleaf. Flagleaf equates to the ear leaf on corn. Look at the coverage I'm getting here. I'm getting complete coverage of that flagleaf, so I'm protecting yield. This is a twin cap system, so I'm comparing a ground-applied sprayer to a ground-applied sprayer. A twin cap is not one nozzle coming down, it's 2. So the whole thought process is I'm going to get more penetration with it, but I'm getting vastly better coverage with Undercover. And then when we come into the lower tillers, that's where the disease starts. So it's just like corn. I need to get penetration. I need to get down in there. Look at the Undercover coverage versus twin cap. And then when we think about yield and the stem heads, we're getting both good front and back coverage with Undercover versus the twin cap is getting decent coverage here, but we're basically ignoring the back. So it's important to think about all the possibilities that we have with both of these systems. And what's really exciting is what if we could do both applications at the same time? And we're going to demonstrate that with this Miller in just a few minutes. But Greg mentioned Hagie is coming out with a dual application system. I mean, as a farmer, that's extremely exciting to me because I could go out and do a V10 to V12 nitrogen application at the same time that I'm doing a fungicide application. So anyway, my wife's not here, so this won't ruin her Christmas surprise, but she's going to get a Hagie underneath the Christmas tree. I give until it hurts. So what we're going to do is we're going to go out, and Jamie Brand and Aaron Phillips are going to kind of lay out what our engineers have done to make sure that our placement is always precise, both from the Undercover and the Y-drop standpoint. Then we're going to show a live demo with this Case sprayer coming through the field. He's got the Undercover under the canopy about 18 inches, and you can walk out there and you can touch and feel. It's just water, but you can see what type of coverage we're getting. So when we think about aphids, we think about spider mites or even fungicide app, what kind of coverage we're going to get. We're then going to talk about the wider window of application. Here I've got a side dress bar. So Greg showed the difference between Coulter and side dress. What if we could also magnify that by getting later application? We're pushing into that window deeper and deeper. We're able to go out here in V9 corn. We couldn't do it with a Coulter because with a Coulter we're going to be slicing roots off. And I want you to go out in the field when this is happening and see that precision of placement. Because it's easy for me to put pictures up here, but when you see it happen real time, it's an absolute convincer. Then we're going to come out with the miller. We're going to go out in this V11 corn, do an application down, and then we're going to come back in that R2, R3. We're going to give you a chance to see the spray patterns coming out of the undercover. So it's a great hands-on. We're going to take questions the whole time that we're doing it. So if you have a question, even if it's one-off, come up to Aaron, Jamie, or myself, and I will repeat it so everybody can benefit from the answer of the question. So Jamie, with that being said, why don't we move everybody out here? And Jamie, give us a rundown of some of the features and benefits of the product.
One thing that we really wanted to focus on is number one, these sprayers need to do a lot of different things on your farm, and now we're looking at having the ability to have a wide window of application with side dress as well. So the biggest thing is you guys have wide drop the next morning. You guys decide in the shop you want to go hit those last 200 acres of beans, but the wide drop is on that system. So what are your options? The biggest thing is the way the engineers designed this is a very quick way to go from spraying back to side dress. So you'll see all these hoses hooked up here on the nozzle bodies. So usually we'll have it down, we'll have one of the hoses hooked up. You come, you pop these pins, you drop it, you bring it out, you set it by the shed, and you just keep going down the row. So basically the way this thing is designed is to come out and they continue engineering our brackets to stay away from our T-jets. So basically from here all the way back, the 2 points of contact can just stay on the machine and you can go out and spray soybeans. You get done with your 200, you flush it out, you bring it back, you snap it up, you put the pin in, you run them up, you turn your nozzle body back to where you need to go and you're back wide dropping corn. So I know on a 24 row system, 23 wide drop systems, 2 guys, 20 minutes is not unusual for you guys to be able to go back, to be able to go back and forth. So that's the efficiency of being able to go back and forth quickly. As we look at this place, every part of this is heavily engineered. You'll see this 3-inch spring here, which there is a pile of springs laying at R&D trying to get that right resistance, right stabilization that we need to be able to go through. It's all about crop safety and placement. So you'll see with this spring, the ability that it's not just here floating. There is a cable in here in case this would break. But a lot of people ask me with this spring, you know, if you hit something, how forgiving is this spring? So, you know, we can come back. It comes right back to where it wants to be. We can go from side to side. If we get into a contour, we need to do different things. Obviously, what we want to do when we're going down that row is we want to reduce chatter. We want to be firm, but we don't want to be too firm. As we keep going down the posts, we get to the undercover, which you guys will see on this case coming out. There is no wide drop on that case. This thing is moved down to where they want it. Gives you the ability to go through and do your undercover very efficiently. We do not sell this with tips. We don't know what you guys want to do. We don't know for sure the gallonage. We don't know what kind of crop that you're doing. But typically on corn and on these beans, you will see that we have our tips in the top 3. So we're basically painting the sides and we're blowing up the canopy. So that is the undercover. As we come down, we get to our variable rate nozzles. And the question is, what does variable rate nozzles mean? What that means, and we're taking a variable rate nozzle to each hose to make sure that we're getting a good even flow out of each hose. These variable rate nozzles are green leaf. And so basically it will give you about a 50 to 60 to 70 pound of nitrogen range. Kind of depends, but if you say, you know what, I'm going to try to go from 30 pounds to 70 pounds and I want to drive 8 miles an hour, your range of pressure is going to go anywhere from about 20 to 70. Now these tips will go up to 140, Most people, when I say that, are saying we're going to have a weak link before we hit 140. So we do have the ability. There's an orifice and a spring. As we get down to these bases, it's kind of like a planter. All the way in is 20. Most people are in the second notch for 30s or in the third notch. So the biggest thing that we want to do is we want to have some resistance on this hose. And when you guys watch that pull type go through, you'll see these hoses working. One of the biggest problems that we have from a placement standpoint is we maybe do not have this adjusted right and we don't have enough keeping it where we need to, or we're carrying them too high and we're pinging off dirt. What we want is we want to have basically our hands to float over. So if we got a clod, we float over and we continue down the path as far as where we're going. Next step is, here's where we are today. Great for 20, 30-inch corn on and above. We continue to engineer and develop. This one will get us down to 15. So we'll have the ability to go out to 30s, 20s, 15s. And then you'll see on that miller, as Jim Hedges mentioned, when that thing comes out after being through there 15 times, we are not seeing any leaves on this shield here. So you'll see this one doesn't have it. This will be an add-on that will have the ability to add on. So we continue to improve the bracketing. The biggest thing is, number one, can I efficiently use this machine for multiple applications? And secondly, once I get it on, am I going to get the placement that I want? So any questions on that you guys have? Yes?
How much of a slope have you been able to run these on without seeing crop damage from the Y drops tilting to the side?
The biggest thing is, the question was, are we seeing, what type of terrain can we go on and efficiently with the spring and everything? As we look at, there's different types of sprayers. There's rear mount, there's front mounts. As we do get into some of the terrain, the front mounts will slice through. They're driving, whereas some of the rear mounts will dogleg a little bit as we get into some of that. So we're having a tremendous amount of success with front mounts just cutting through. And it's ahead of them front tires by just a little bit, and it's just slicing through. If we do get on some slopes and different things with the radial tires, we're squatting and doglegging a little bit, but we were able to run through some pretty good terrain with both the rear. If we get into a little more challenging, then the front mount probably would be the preferred method. That's why Jim's having one under his Christmas tree.
Okay, let's move on over. Aaron, if you want to call the case. They're coming in here, they're about chest high. These are 30-inch row beans. But we have had, I'm in 20-inch rows. I've treated all my soybeans with this system. And we actually had a dealer, his name's Jay Springer, up in northern Illinois, where they had a lot of white mold. They used the undercover system in drilled soybeans, so 7-inch row soybeans. So I think we've got a lot of opportunity in all row widths. Once again, we can change the depth of the canopy we're going to go into with the undercover based on what we're trying to kill or what we're trying to treat for. Is it disease? Is it micronutrients? Those types of things. As he's coming through here, he's running around 8 miles an hour. He's using about 60 PSI, and he's applying, as Jamie said, about 16 gallons per acre. When he comes out the end, I really want you to look at the spray pattern because it is impressive and it gives you an idea of why this paradigm shift in let's not apply from the top down, let's go bottom up. It's a totally new concept, but it's a concept that's going to have dramatic impact on yield. So you can see that spray pattern. I love it when he gets out into the sunlight so you can see how much coverage we're going to get. If anybody wants to walk out in there, you can. One thing I'll point out, this is the 5th time that we've had that sprayer down that same set of rows, and we've created very little damage in the crop. It's the same with these other passes as well. So a question I just received is, are guys looking at herbicide applications with this as well? Truly, our focus is around fungicide, micronutrients, and insecticide, but we have had people, particularly in corn, when Roundup is off label, go in with the drops so they can get back on label and just put in the right nozzles to get very good herbicide activation as well. Okay, so the question is, what about nozzles on the top as well? And we've done some work, particularly in seed corn, around what about top down as well as bottom up? And we get tremendous coverage from that. Is it enough better than just the under coverage to amount to something? We don't know. We have to take it out to yield. With fungicide apps on seed corn is where we've been using that type of technology. Any other questions on the undercover?
Before, why did we stage corn? Was it for nitrogen application or was it from a crop safety standpoint for chemicals? And it was typically for chemicals. So really what we were able to do is we were able to run around through the field and find a leaf that still looked like your thumb on the bottom right, and you could count up. Well, now the soil scan is going to ask you what stage your corn is, and it's going to be V10, V12, V14, whatever. So basically, what I would recommend is just getting a plant out. You're going to have to put it on your tailgate. Look, these are collars. So it kind of looks like a collar of a shirt, right? So once those collars are out, that is your top spot. Now if you look down in here, we're trying to build the shirt yet, so we don't have a collar. So you want to come here and you want to find this first collar. The leaf right below it, I usually tear off, and I get to this node right here. This leaf of this last collar hooks. It hooks up on the higher one. It actually hooks, you'll see it here in just a second. It hooks right here. See my collar? Here is my first node. So what you want to do is mark this with a marker, and the next thing you want to do, and so that's the last one you will count. Then you come to the bottom, you split it, and I apologize, this one got kind of dirty on my knife. But basically what you're going to see in the bottom, if I can clean that a little bit. The key is to have a clean knife. So what you're going to see on the bottom, actually you can still see where the seed was. There are 4 right here. So that triangle, the size of a permanent marker, is 4, 5, 6, 7, 8, 9, 10. You can see right here an ear shoot. And what you're going to do is keep going up until you find where you marked with the marker. So it's different than what we've historically done, because usually when we were looking at herbicide application, we were able to still find. How many of us ran around a field trying to find the one with the thumb leaf left? Because we're like, man, then I got to cut the thing and it's pain. Now we don't even worry about what's below. So that's an important part of being able to put that. You know, there's a big difference between B11 and B13. So
yeah, the critical thing about that, and Jamie, you and I have talked about this, is you can't go by plant height, because different environmental conditions can make the stalks elongate more, so you'll have more distance between those internodes, or they can be tighter. And I know back when we were studying accent, some people were going off the label saying, oh, it's 14 inches tall, when it was actually a couple leaf stages beyond where the height was on the label. We had a lot of damage. So understanding that is really critical. Okay, so what we want to do now is demonstrate the placement on this side dress bar. One thing I want to point out about the side dress bar is Greg used Randy's field as a demo of Coulter versus Y-drop on a side dress bar. We saw 8.5 bushel projected difference. I think we can magnify that because we're going to be able to go out. This is V9 corn, and he's getting through it fine, so we can push into that window when the corn is hungry. We can't do that with a Coulter because we're going to be cutting too many roots off. So we're not only going to get better placement, but we're going to get a push into the extension of the window where that corn's really, really hungry. So I think we'll get another magnification yield. So anyway, Aaron's going to take off. I would encourage you to follow him in so you can see the precision of the placement. Okay, we're going to prep up. This is the Miller. Now we've customized this to have a split tank so we can do both a fungicide as well as a nutrient application at the same time. The things that I want you to pay attention to is we're going through V11 corn as well as V9 corn. Look at the coverage. This is really impressive after he goes in to see what type of coverage we're getting, basically top to bottom of the plant. He's then going to come back in the R2 to R3 corn, so that 10-foot tall corn. And I want you to look at those boots when he comes out because we have basically no leaves on those boots. The only place you might see some leaves is where we've got the connectors set up so we can quickly move from 30-inch rows to 20-inch rows. If we were actually doing application on wide acre basis, we would pull those off in corn that's at this stage of the game. Once again, he's just applying water, so if you get a little misting, it's only water. So
springs in that one, don't you?
yeah.
Good.
Yeah. So I just had a question about, we've got breakaway springs on that. We do. One of the things that we're working on is an option to have breakaway springs. So if you're in rougher grade, so you're not flat like this, we get more forgiveness. So we're working to get about another 3 foot of forgiveness so you don't cause any boom damage. If you look here, you can see the tremendous coverage we're getting with this type of application methodology. One of the thought processes on why we would want to go out and do V10 to V12 fungicide applications is, can we eliminate the V5 and VT application and get the same type of effect with the V10. That way, once again, we've never allowed the disease to set in. To me, it makes no sense to get to economic threshold. If we hit economic threshold, we've already caused yield potential to be lost. So this is the blocking strategy. And the thought of coming out and doing both a V10 to V12 application of fungicide and nutrients, particularly nitrogen, is powerful. It gives us the ability to do things that we never thought we were going to be able to do. So this is a whole new set. It's a new paradigm around tools in nutrient and plant health for us to think about. So the question is, how many gallons of Preaxor were we putting on? We're doing research trials to get anywhere, go from 20 gallons max down to 10 gallons. We believe by getting into more stomates, we're probably going to be able to use less volume of liquid, so we'll get more efficiency out. Here, take a look at him coming in here. This is almost surreal. It's the coolest thing that, or one of the coolest things you'll ever see as a farmer. And once again, this is the 5th time we've been through here. We're causing very little crop damage. So look at the, as you look at the boots and look at the spray pattern, so as you look at the boots around that, you see there's very few leaves. There's no leaves on the undercover. So even in corn, it's R2, R3, we're able to go through and cause basically no damage.